Hello friends, so in this video I will talk about the stopping power of a radiation. So here radiation is basically muon plus and it is inside the copper material. So on the y-axis you have the stopping power. You can just see this plot on the Google, and then on the x-axis is the muon momentum, how stopping power varies with the momentum. So initially stopping power basically rises and then it basically decreases as the momentum become higher and higher, and then we have again it starts increasing. So these there are several regions like minimum ionization, which I basically explained in my previous video. I will put the link in the description box. So this is basically the low momentum regime like 0.1 MeV per C to 100 MeV per C, and then this is 1 GeV to 100 GeV, and then 1 TeV to 100 TeV. So there are several regions. So this is particular region where the loss works, and then we have a radiative region, and then we have the nuclear losses. These all things are you can see it, and this is basically the stopping of the muons in the copper material. If I want to extract, let's say for example, protons in the some material, then how can I extract? For this there's a link that allows you to extract similar plots. So let's go to the link. So the link is basically, you can use this link to evaluate the stopping power and the range table for electrons, protons and helium ions. So it allows you to get the similar plot for electrons, protons and helium ions in any kind of material. So I will put the link in the description box. So which basically library it is using? This basically uses the data from the National Institute of Standards and Technology, NIST. It is the data, it provides the data which is very useful in the case of GEANT4. So for example, if I go to the GEANT4, then if I define a material basically, okay, so if I define a material, we have a class G4 and NIST manager, and that basically allows you to access the any material properties. So basically this is NIST is referred to this particular National Institute of Standards and Technology, and I will put the link in the description box. So you can just see also NIST material builder. It's the class of GEANT4, and you can also see the database on the GEANT4 website. This basically also mention the NIST compounds, which if you click on it you will get all the data for the compound. So it is very useful in the GEANT4 to define the material properties. So also you can click on this link on this class. I will put. So let's say open this link, how it looks like. Okay, if you open this link, it comes here again, National Institute of Science Standards and Technology. So then you can just see if you want to access the data, so you can click on all elements and then you can get the data. So you can just see, you can get the data of, for example, hydrogen. We have the isotopes, hydrogen, deuterium, tritium. These all data is available on this basically for the compounds, and these all things is you can easily find on the NIST library. So this is highly used in the GEANT4 to define some element or compound properties. So let's go to the our stopping power plot. So this is the link for to evaluate the, for example, the stopping power plot. So it has the program that allows us to evaluate the stopping power. So there are three basically given. As I told you, E star is basically stopping powers and range for electrons, and then the P star and the A star for the protons, and the A means alpha means helium ions. So alpha particles you can also do for the alpha particles. So to access the data, what you have to do, you have to click on this link. Let's click on the electron. So now it explains the E star program calculates the stopping powers, these all things up to energy range of 0.001 MeV to this particular MeV. So it allows you to calculate the total stopping power and collisional and then the radiative, all things you can also choose the others. So if you just, now you have to select the material in which you want to evaluate. So for example, you can choose, now my incoming particle here is electrons, radiation is basically electrons. You have to choose the target, you can choose the silicon and you can also submit here. So then you can see the all the two effects. Collisional stopping power is in the, let's say, in the red, and then you have for example the radiative stopping power and then the total stopping power. These all things you can easily evaluate in this case. So since we already have seen the stopping power of electrons in the silicon, then we can also evaluate the stopping power of electrons in the copper. So you can just select the material, you can select the material. So copper is basically 29, so you can just select that and then you can just basically plot it. So now you can basically again see the stopping power of electrons in the copper. You can just see all the energy scales, and what you can do, you can see the collisional energy loss in the red, and then we have the radiative stopping power, and then we have basically the sum of the two. And you can also access the data. So you can basically download this data. You can just select this particular and then you can basically click on download data, and then it will basically create a it will basically, you can just click on it. So then it will show like this, and you can basically copy paste in a text file. I will show how to plot this data in one case. Then you can just copy paste in a text file that can be directly plotted in this the plot we are seeing like this. So you can basically easily create these types of plot. So this basically is for the electrons. Let's go for the another particle. So we also have the for the proton. So let's click on the protons. So in the case of protons, we have again the total stopping power, we have the electronic stopping power, we have the nuclear stopping power, and these are the other things available, CDSA range and the projected range. These all things you can plot it. So let's see now it will P star basically program calculate the stopping power and the range for the protons in different materials, so various materials. So now I can again choose the one of the cases silicon. Okay, then I can submit and it will show the two kind of stopping power. So one is the nuclear stopping power, another is the electronic stopping power. So electronic stopping power with basically ionizing radiation because of the ionization, and then the nuclear stopping power because of the nuclear interactions, and then the total is shown by the black line. And you can again access the data, you can just download it. So you can just click on the download data, you can select whatever columns you want in your data, and then you can download data, and then this way you can download the data easily, and you can evaluate, you can choose any material in which you want to evaluate the stopping power. Now for example, copper is the 29, we know silicon is 14 atomic number, and then copper is 29, so you can select the, and then you can basically submit it. Now it will evaluate in the copper. So the stopping power of the proton in the copper. So then you can basically again see the nuclear stopping power, how it goes, and the electronic stopping power and the sum of the two contributions. And you can again basically evaluate the download the data. You have to select this what you want in the table, so this particular, and download data, and then it will show this particular file, and you can just select by Control A, and you can copy paste in a text file that can be directly plotted. So the next program, we also have one more program, is helium ions. So that also allows you to plot the stopping power. For example, for the helium, basically alpha. So for example silicon, you can just also choose the silicon, how it varies. So you can again plot in the silicon, you can just see the silicon, and then the electronic power, stopping power, and nuclear so in the previous case of proton, for example in the protons, I already downloaded this file for the, let's say, copper. So I downloaded this file. So how I downloaded this, the data, so these are the electron and nuclear and the total stopping power, and then I select download, and then I copy, control A, copy, and then I paste in this particular data format. So I created the data.txt, and then basically I copy paste all the basically data which I selected here. And then for the plotting this data, we can easily use the root. I write a simple macro, I will put in the description box, you can easily plot it. So then I basically written a macro, root minus L, draw same dot cpp. Now you can see, you can easily plot the data using the multigraph and t-graph. So you can just see it, I on the electronic stopping power and the nuclear stopping power, and then the sum of the two contributions in the black, total stopping, and the kinetic energy and the stopping power. So this looks like the similar plot what we are seeing on the website. You can just see it particular in this case. So how the macro is written, let's go to this. So for plotting it, the data format is basically, we have that 4 columns. One is for the energy, and one is electronic stopping and nuclear stopping, and the total stopping. So I plotted like this. So we can use easily to read a graph. So you can use the data text file, and which you can easily use to read the data basically. And then basically I put the t-graph formats, and then you just basically add these all three graphs, and then you put the legend. So I will put this macro in the description box. So this basically link can be helpful if you want to evaluate the, for example, stopping power inside any material. So you can easily choose anything, like for example muscle, skeleton. You can also do these all things, you can easily do it, and the projector range, these all things you can quickly evaluate in this program. So I hope this will be very helpful if you want to evaluate, like for example stopping power quickly using, and you can use the data to plot, you can use the root to plot the data basically. So thank you all.